Welcome to this lecture. Till last class we had seen how to evaluate Z transforms for simple basic functions. In this lecture we are going to see how to evaluate Z transforms for quite complicated functions using specific properties of the Z transform. So this is the definition of Z transform as we had already seen in previous lectures. Z transform for a sequence f of n is summation n equal to 0 to infinity f of n z power minus n, and it is denoted as capital F of z. Let us see the elementary properties which we had already proved before starting the problems. So this is the first linear property of Z transform, that is Z transform of two functions can be written as sum of their Z transforms individually. And second is frequency shifting property, that is Z transform of a power n f of n is actually f of z by a, that is z will be transformed to z by a. And the third property is differentiation in the z domain, that is when you differentiate f of z and you multiply z, you actually get Z transform of n into f of n. And the last property is called as first shifting property, that is if Z transform of f of t, that is your time function, is f of z, then when we attach an exponential function like this, that is Z transform of e power minus at f of t is going to be function of z e power plus a into capital T. So this is the transformation in this property. So having these basic properties of Z transforms, we are going to do problems for some specific functions wherein we will be using one of these properties. So let us see how to do that. The first problem, evaluate Z transform of n squared, n cube and etc. And similarly for some positive power of n, that is for n power k. So first let us see how to evaluate this Z transform of n, the Z transform of an integer n. This is the definition of Z transform. As you all know, Z of sequence f of n is summation n equal to 0 to infinity f of n z power minus n. So now when we need Z of n, in the place of the sequence here now we have n. So go to the definition and in the place of this f of n, now let us substitute n into z power minus n we have. Now bring that z power minus n as 1 by z power n like this. And now let us expand the series, that is the first term putting n equal to 0, you get 0 here. Now put n equal to 1, you get 1 by z power 1. Then when we put n equal to 2, you have 2 by z squared plus etc. So this is the series we get, and we should apply the appropriate formula to find the answer of this particular series. And when you look at the series now, we can observe that there is an 1 by z common in all the terms. So let us first take that common term out. So when we take that 1 by z, which is a common term, outside, here we have 1 plus 2 by z plus 3 by z squared plus 4 by z cube, and which will be closely related to this formula. So this is a basic binomial series formula, 1 plus 2x plus 3x squared plus 4x cube, which is actually 1 minus x the whole power minus 2. So is it not of the same format, wherein you have in the place of x, here you have 1 by z. So as per this formula, this is going to be 1 by z into 1 minus x the whole power minus 2. That is the answer of this series. So in the place of x, here you have 1 by z. So it's going to be 1 minus 1 by z the whole power minus 2. So this is going to be the answer of Z transform of n. Just we need to simplify to write it in a neat format, that is 1 by z into taking LCM. You have z minus 1 by z the whole power minus 2, and you can reciprocate this as z by z minus 1 the whole squared. And here you can see this is z squared and this 1 by z will be cancelled. So here you will have z divided by z minus 1 the whole square. So this is the answer of Z of n. Now when we proceed like this, Z of n squared you can write as Z of n into n, and look at this property. When you have n into f of n, you can remove this n and the final answer will be minus z d by dz of f of z. See, actually this f of z will be Z transform of f of n, that is not having n. So using this differentiation property, we are going to evaluate z of n squared. See here I have written the property here. So z of n squared can be written as n into n. So we are going to remove one n. So removing one n, you get by the property minus z d by dz of n, which is the f of z here. And this z of n, just now we have calculated z by z minus 1 square. So let us substitute here. See, the z of n answer is z by z minus 1 the whole square. And now we need to differentiate this. So we know how to differentiate u by v format. So divided by v squared we should write first. And on the top, keeping the denominator, first we should differentiate the numerator. That is z when we differentiate 1. Minus, keeping the numerator, we have to differentiate the denominator. So this when we differentiate, we get 2 into z minus 1. So this is the differential of this term. And now when we look at this, there is a z minus 1 common, so which can be taken out. And here you have z minus 1 minus 2z divided by this. So the final answer is, after cancelling the z minus 1, here you have z into simplification of this is 1 plus z divided by z minus 1 the whole cube. So this is the answer of z of, that is z transform of n squared. See here, z transform of n squared. Now let us proceed further to find z transform of n cube. Same property we are going to use. So n cube can be written as n into n squared, and we shall remove this n. So it's going to be minus z d by dz according to this property. Minus z d by dz of z of n squared. And just now we have calculated what is z of n squared. See here you have. So this z of n squared answer is, here you have the answer, z into 1 plus z by z minus 1 the whole cube. So this z of n squared answer we have substituted. And now we shall differentiate this. So as usual, u by v, we know how to differentiate, divided by v squared. So this is v, squaring this. And on the top, keeping the denominator, first we should differentiate the numerator. So this is z plus z square. So when we differentiate, 1 plus 2z. Minus, keeping the numerator, see we have multiplied this, into differentiate the denominator. So this when we differentiate, 3 into z minus 1 square. So this is how we should differentiate u by v format. And now just simplification, you can take z minus 1 whole squared common here into, just you need to simplify, and the final answer will be this. So like this, see this is z of n cube. Like this we can continue to find z of n power 4, z of n power 5, etc. So for any general z transform of n power k can be found using the method what we had followed for z of n squared, z of n cube, etc. Now let us go to the second problem. Find z of t square, z of t cube, etc. And whenever this t format comes, like we should remember, t should be replaced as n into capital T, where this capital T is the time period, which is a constant actually. So let us rewrite this t, wherever t comes, small t comes, let us rewrite as n into capital T. And since this capital T is a constant, it can be taken out, and this is going to be z transform of n. And in problem 1, we have got the answer of z transform of n here. So here this we are going to substitute here, z transform of n. Similarly, z of t square will be n square t square, and capital T square is a constant, can be taken out into z of n square. And what is z of n square? Here we have the answer of z of n square. See, this is z of n squared answer. This has been substituted here. Similarly, z of t cube will be n cube t cube, and capital T cube is constant, can be taken out, z of n cube. See, this is the answer of z of n cube, which is substituted here. So this is going to be just simple, you making use of z of n squared, z of n cube answers what we have already calculated in problem 1. Likewise, we can calculate z transform for any power of t. Now let us go to the third problem. Z of a power n, n square. Here a power n can be removed using this property. Whenever you have a power n into a function f of n, a power n can be removed. Instead we have to put z as z by a. See, z will be changed to z by a. So that's what we are using here. In z transform of a power n into n squared, we can remove a power n, so it will be z of n squared. But whenever we remove a power n, this adjustment should be done, that is z should be changed to z by a. Now this z of n squared, we have already calculated z of n squared here. See, this is the answer of z of n squared. This is the answer of z of n squared. Let us substitute here. See, here we have substituted z of n squared. Here you have to replace z as z by a. So wherever z comes, all the z terms should be replaced as z by a. And just simplification will give you this answer. Now proceeding further to the fourth problem. Z of 3 power n by n. Now look at the z of 3 power n by n. Using the same property, 3 power n can be removed. And so this is z transform of 1 by n. Whenever 3 power n is removed, z goes to z by 3. Here in the place of a, here you have 3. So z goes to z by 3. And z of 1 by n, let us see how to evaluate. This is the definition of z transform. N equal to usually 0 to infinity. Since it is 1 by n, for n equal to 0, this becomes infinity. So we should start from 1 to infinity, 1 by n z power minus n, and bringing z power minus n to the denominator and expanding the series. Putting n equal to 1 you have here, putting n equal to 2 you have this term, putting n equal to 3 you have 1 by 3 z cube, etc. And here when you look at, it is x by x squared by 2 plus x cube by 3 format. So here this is a formula we need to substitute. See, x squared by 2, x cube by 3, the same format here you have. So this is the answer of this particular series. So here in the place of x you have 1 by z. So according to this formula, answer of z transform of 1 by n is going to be minus log 1 minus 1 by z. So just a simple simplification, taking LCM and taking this minus to the power and reciprocating log z by z minus 1. So this is the answer of z of 1 by n. Hence z of 3 power n by n is going to be z of 1 by n, where z goes to z by 3. See, this is z of 1 by n. Let us substitute that answer what we have evaluated. And in this answer, we should apply z goes to z by 3. So z goes to z by 3. And just simplify. So the final answer is going to be log of z by z minus 3. Now let us do one more problem. Find in time function. Determine z transform of e power 2t t cube. See, e power 2t into t cube. And for this we should make use of this property. So whenever you have z transform of e power minus at f of t, the final answer is capital F of z e power at. So let us make use of this property here. Since e power 2t is attached, e power at term can be removed. So I am removing this e power 2t out. So it is the z of t cube. See, whenever we remove e power minus at, z goes to z e power plus at. So here we are removing e power 2t. So z goes to z e power minus 2 capital T. See, here small t means final answer will have capital T. Minus a means plus a in the answer. Similarly, here plus 2. So here minus 2. Small t will be transformed to capital T. Now what is z of t cube? See, in the problem, I think in the second problem we calculated z of t cube. So here this is z of t cube. Let us substitute that answer here. So this is z of t cube answer which we have already calculated. So in this z of t cube, see, z of t cube, t is nt. We know that t is nt. So n cube t cube, which is capital T cube, into this is z of n cube. Already we had seen all these in problem 2. And so this is z of t cube. In z of t cube, we have to substitute z goes to z e power minus 2t. So we should apply this limit. So z goes to z e power minus 2t. So after finding z of t cube answer, we should apply this rule. That is, all the z terms should be changed to z e power minus 2t. So here this z is z e power minus 2t, and z squared will become, when you square this, z square e power minus 4t. And this z is z e power minus 2t, and this z is z e power minus 2t, the minus 1 whole power 4. That's it. Just in the place of z, we have to change z e power minus 2t. So this is going to be the final answer for this z transform. So I think you would have learned using all variety of properties of z transform. So make use of these concepts to evaluate these two problems. Thank you.